Good morning all, I am Mahin Fatima studying CSM in Srinivas Ramanujan Institute of Technology. My linear algebra and calculus assignment topic is Lagrange's theorem of undetermined multipliers. Let's go into the topic. First, what is Lagrange's method of undetermined multipliers? We have working rule. Let us see the working rule first. Suppose it is required to find the extremum for the function f of x comma y comma z subject to the condition phi of x comma y comma z equals to 0. We have from Lagrange's function f of x comma y comma z equals to f of x comma y comma z plus lambda phi of x comma y comma z, where lambda is called Lagrange's multipliers, which is undetermined by the following conditions. Next, step 2. Obtain the equations dou f by dou x equals to 0 implies dou f by dou x plus lambda dou phi by dou x equals to 0. Similarly, dou f by dou y equals to 0 implies dou f by dou y plus lambda dou phi by dou y equals to 0. Similarly, dou f by dou z equals to 0 implies dou f by dou z plus lambda dou phi by dou z equals to 0. Next, step 3. Solve the equations 1, 2, 3 and 4. The values of x, y, z so obtained will give the stationary points of f of x comma y comma z. For example, if we take this example, find the point on the plane 3x plus 2y plus z minus 12 equals to 0, which is nearest to the origin. Solution for this: let p of x comma y comma z be a point on the given plane. Let O denote the origin, and the distance between the point and origin OP equals to square root of x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square implies root x square plus y square plus z square. Next, consider f is equals to x square plus y square plus z square. This is the distance between OP. We declare one variable f is equals to x square plus y square plus z square, and the plane phi is equals to 3x plus 2y plus z minus 12 equals to 0. From Lagrange's theorem, f of x comma y comma z equals to f of x comma y comma z plus lambda dou phi of x comma y comma z. That implies x square plus y square plus z square plus lambda 3x plus 2y plus z minus 12 equals to 0 minus 12. We substitute f of x comma y comma z and phi of x comma y comma z in Lagrange's theorem. We get this equation. Next we find the partial derivative, first with respect to x, next y, and then with z. That is, dou f by dou x equals to 0 implies dou f by dou x plus lambda dou phi by dou x equals to 0. That equals to dou by dou x of x square plus y square plus z square plus lambda of dou by dou x of 3x plus 2y plus z minus 12. If we do this if we do f of x comma y comma z with respect to x, we get 2x plus 3 lambda equals to 0. Let us consider it as equation 5. Similarly, dou f by dou y equals to 0 implies dou f by dou y plus dou phi by dou y equals to 0. That equals to dou by dou y of x square plus y square plus z square plus lambda into dou by dou y of 3x plus 2y plus z minus 12. Now we differentiate with respect to y here. We get 2y plus 2 lambda equals to 0. Let us consider it sixth equation. Next, similarly, dou f by dou z equals to 0. That equals to dou by dou z plus lambda dou phi by dou z equals to 0 implies dou by dou z of x square plus y square plus z square plus lambda dou by dou z of 3x plus 2y plus z minus 12. We get 2z plus lambda equals to 0. Let us consider equation 7. From 5, 6, 7 equations we get 2x equals to minus 3 lambda, 2y is equals to minus 2 lambda, and 2z is equals to minus lambda. If we take x from first equation, x we get minus 3 lambda by 2, y is equals to minus lambda, z is equals to minus lambda by 2. Substitute 8, 9, 10 equations in 3. In third equation we get 2 into 3 lambda by 2 plus 2 into minus lambda plus minus lambda by 2 minus 12 equals to 0. If we take the LCM, 2, we get minus 4 lambda minus lambda minus 24 equals to 0, minus 9 lambda minus 4 lambda minus lambda minus 24 equals to 0, minus 12 lambda minus 24 equals to 0, lambda is equals to minus minus 24 by 14, we get minus 12 by 7. Next, using these values in 8, 9, 10 equations, that is 8th equation is x is equals to minus 3 lambda by 2. If we substitute lambda, we get minus 3 lambda by 2 into minus 12 by 7 equals to 18 by 7. Y is equals to minus lambda, that is equals to minus of minus 12 by 7 equals to 12 by 7. Z is equals to minus lambda by 2, that equals to minus of 12 by 7 into 1 by 2, that equals to 6 by 7. And so we get the point 18 by 7, 12 by 7 and 6 by 7 is the point on the given plane which is nearest to the origin. Note, minimum value of OP equals to get the minimum value of OP, square root of x square plus y square plus z square, that is equals to square root of 18 by 7 whole square plus 1 by 7 whole square plus 6 by 7 whole square, that is equals to 6 root 14 by 7. That's it for this. Thank you for giving me this wonderful opportunity. I hope you found this video insightful.